Hello friends, how are you? I hope the way we completed our topic discussions, now definitely you are finding yourself in a much comfortable position. So we decided to start a new type of activity, that is to provide you questions based upon JEE main pattern, JEE advanced pattern, CBSE pattern and NEET exam pattern. Fine. So here in that particular sequence, I am once again back with a new video. Here I am going to provide you some questions. Fine. These questions are for the purpose of providing you a first hand knowledge of your you can say understanding, how much you grasp. Fine. So these questions are going to give you a review, overview or internal analysis of your learning skills. Fine. Try to understand the phenomena, that is involved in each and every question, and then try to revise and learn the topics more properly. So here one by one, first I will explain a question, obviously the solution. Fine. So you can try to understand what exactly the problem is and how exactly we are discussing the solutions. So from now onwards, just I am going to devote time on the question explanation, answer, questions, answer in this fashion. Fine. So here comes your first question, that is a simple one, but first I would like to explain you. An object is placed 10 centimeter away from a glass piece. Okay, refractive index is given and the length of the glass piece is 20 centimeter. Bound by spherical surfaces of radius of curvature 10 centimeter. So let us try to draw this diagram. First, fine. That is this way and in this fashion. Fine. So now first line has been translated and this entire length is 20 centimeter as it is given over here from this point to this point, and radius of curvature 10 centimeter. So you can say ROC 10 centimeter, you can say ROC 10 centimeter. Fine. After that, find the position of the final image formed after 2 refraction. Twice refraction means 2 refraction. Okay. So object is placed 10 centimeter. So object is placed obviously like this. This is, you can say, the principal axis. This is point B. This is point A. Fine. So you can say the object is placed. So let's say this is the object and then the distance is given 10 centimeters. So this gapping is 10 centimeter. Now I hope the question and the you can say the diagram is clear to all of you. Fine. As such, nothing is so difficult over here. Twice refraction means once and then 2. So over here it's air, its mu is equal to 1.5. Fine. This is glass piece. Now we have to find out the position of the final image formed. Fine. Now 2 refractions taking place. First refraction, second refraction. First from rarer to denser, second from denser to rarer. Okay. So one by one we will calculate. So first refraction, fine. First refraction means I am just putting the values because every term I explained and the values given in this question, they are also simple. So it's going to be 1.5 upon V1 minus 1 upon minus 1 by 10, ultimately it will give you plus, is equal to 1.5 minus 1 upon plus 1 0, that is 10. Solving this simple equation is very easy. So, what you can say? You can say after solving V1 is equal to minus 30 centimeter. Fine. So, this is the situation after first refraction. Okay. What will happen after second refraction? So, just note down this value, let us say over here, that is V1 is equal to, V1 is equal to minus 30 centimeter. Fine. So, now what I will do? I will erase out this portion and apply the same concept for second refraction, because it is mentioned twice refraction. So, it is second refraction, okay. Second refraction means once again we apply the same formula which we just applied, that is 1 upon V2 minus 1.5 upon minus 5 0. I hope terms are clear. Minus 3 0 and then this distance. So, minus 5 0 is equal to 1 minus 1.5. I am not doing anything complicated, just I am putting the value in your well known formula 1 upon V plus minus 1 upon U is equal to 1 upon F type of relation. Fine. So, 1 upon V2 minus 1.5 upon minus 5 0 is equal to 1 minus 1.5 upon minus 10. Fine. Once you solve this simple equation, you will get V2 is equal to plus 50 centimeter. So, answer is going to be, image will be formed at 50 centimeters from B. Fine. So, C is the correct answer, and let me write down the complete answer. Final image at 50 centimeter from B point. Fine. So, this question was not a difficult one, a simple question and a very simple answer in this fashion using the same formula twice. So, now I hope I should clean up this board and go for the discussion of the next problem. Fine. See, for JEE mains, if you analyze this year's paper, questions were quite simple, but we are providing you material so that you can equip yourself to handle any type of questions. Fine. This is the best approach. We are, anyway not ready to take any type of risk or chance. So, now here comes your next question, that is a convexo-concave diverging lens. Convexo-concave diverging lens. Okay. Convexo-concave diverging lens, I hope that term is clear, is made up of glass of refractive index this much and focal length have 24 centimeter. Radius of curvature for one surface is double that of the other. So, if one radius of curvature is capital R, another is twice of capital R. Then find radius of curvature for two surfaces, definitely in terms of centimeters. So, this combination is, if one is say x, so another is going to be 2x. So, 6, 12, 12, 24, 3, 6 and so on. Fine. So, let us try to find the solution of this problem. As such, no diagram or nothing is required. So, what I will do, I will simply write down the formula, put the values, we will try to find the solution. Fine. So, let us write down the formula. It is a well known formula to all of you, because now the question is clear. So, I hope I can use this space also. So, if it is going to be hidden, please do not mind it. So, the formula which I am going to explain you, that is 1 upon F is equal to mu2 minus mu1 upon mu1 within bracket 1 upon R1 minus 1 upon R2. I am sure you all are aware with this basic formula. Fine. I hope it is clear to all of you. Mu2 minus mu1, mu2 minus mu1 upon mu1 1 upon r1 minus 1 upon r2. Let us try to put the values over here. So, values are going to be minus 1 upon 24 is equal to 1.5 minus 1 upon 1. Fine. Minus 1 upon r plus 1 upon 2r. Now, why I did it? Because it is mentioned that if one radius is capital R, then another is double of capital R. So, if R1 is R, then R2 is nothing but 2R. Let us try to solve it. So, rather than devoting time onto solving this, simply say after trivial solution, after solving, you will get it as 1 by 2 into minus 3 by 2r. Fine. So, ultimately once you solve it, because the value of f also I placed like this. So, here you can say r is equal to 6 centimeter, therefore, that is R1 is equal to 6 centimeter. So, R2 is equal to 2 of this R1, that is 12 centimeter. Fine. So, now answer is crystal clear, that is 6 and 12 and the basic formula and simply putting the values. So, as such these questions somehow slightly different, but as such not difficult to understand. Fine. Basic approach. Ultimately, I would like to share this fact with all of you. Ultimately, the objective of these problems is to force you to think on conceptual clarity. That is it. If in physics concepts are clear, be sure you are going to pass out from this exam with flying colors. Okay? Conceptual clarity is utmost important. At any point of time, if concepts are not clear, then it is going to be a difficult part. So, here I would like to come on to the next question, that is question number 3. Now, this question is very simple, but beautiful. Beautiful in the aspect you have to use only one formula. Fine. And if you realize which formula you are going to use, as such nothing difficulties involved over here. Let me first introduce the Mr. Question to all of you. Yes, Mr. Question. When a lens of power P, moment power P, so one formula should come in your mind, power P is equal to 1 upon F, okay, moment 1 upon F, 1 upon F is equal to mu minus 1 within bracket, next bracket 1 upon R1 plus minus 1 upon R2. Now, you should read in this fashion. So, what happened? With one question you can say revise many formulae associated. Fine. When a lens of power P made up of material of refractive index mu is immersed in a liquid of refractive index mu naught. Now, it is not given either mu is greater than mu naught or mu naught is greater than mu, but because one way we have to find out. So, let us start with one aspect, fine, that is mu is greater than mu naught. Then the power of the lens is how much? Basically, students, here I would like to tell you a fact. If I have a lens of refractive index, let us say 1, let us say 1.5, fine, and if I am putting this lens in a refractive index material of let us say 1.2, lens will not change its nature. But if I will put it in a liquid where the refractive indexes are same, the lens will behave as a plate, and if the refractive index of the liquid is more than the lens, then the lens is going to change its nature. So, these three aspects are also associated. During the discussion of this topic in our regular lectures, I explained this topic to all of you. Now, let us start this solution. Fine. You know, as I mentioned, P is equal to 1 upon F, well known formula. which is equal to mu minus 1 upon 1. Fine. Then 1 upon R1 minus 1 upon R2, 1 upon R1 minus 1 upon R2. Equation number 1, let's say. Fine. Next, when you are putting it inside the liquid, let's say the power is P prime. So, it is going to be mu minus mu naught upon mu naught within bracket, then again 1 upon R1 minus 1 upon R2. Let's say equation number 2. Now, do one thing, divide equation 2 by 1. You can do other way around, fine, no problem, but because you have to find out P prime, so let's do it in this fashion. By 2 by 1, fine. P prime upon P, what you have to do? Put the values. So, this 1 upon R1 minus 1 upon R2 is going to be cancelled, 1 upon R1 minus 1 upon R2 meaningless, fine. So, ultimately they are meaningless for me, fine. Only the values left over is mu minus mu naught upon mu naught into 1 upon mu minus 1, fine. So, you will get over here as mu minus mu naught, it is clearly visible, upon mu naught, and then this one mu minus 1, mu minus 1, fine. So, from here P prime is equal to mu minus mu naught upon mu minus 1 P upon mu naught, fine. So, this is your correct answer, because this P prime is new power. Okay. So, as such the question is not very difficult one, it is a simple question, and simply by applying this formula you can find the result. Again, my emphasis is totally onto this aspect. What exactly? This formula. That is why I am mentioning each and every term of the formula, and these yellow dotted means when you divide 2 by 1, both these terms are going to cancel each other, fine. So, this was a third beautiful question in this particular sequence. Hope you will get the correct feeling of these questions, fine. Let us try to move away from this particular segment to a next question. Now, a quarter cylinder of radius r, diagram is given, and refractive index 1.5, this 1.5 mu for this quarter cylinder. Quarter cylinder means, imagine a cylinder like this, fine. So, if I cut this cylinder, removed, cut this, removed. So, if I am watching this cylinder in this fashion, fine, if you are watching this cylinder in this fashion, you will find only so ultimately what you will get? This, I think, okay, they given it. So, basically this portion is visible, fine. So, this portion I cut out, picked and place over here, that is the problem, fine. 1.5 replaced at a table, a point object P is kept at a distance of mr from it. Find the value of m for which a ray from P will emerge parallel to the table as shown in the figure. So, I think I should draw the resultant ray. As per the question, finally ray should come out like this, fine. This is the aim, this is the target. Okay, so now let's try to find the solution. I hope the problem is clear to all of you. Okay, once again I would like to read. A quarter cylinder of radius r and refractive index 1.5 is placed on a table. A point object P is kept at a distance of mr from it. We are in a process to find the value of this small m. Find the value of m for which a ray from P will emerge parallel to the table or parallel to the principal axis. Fine, actually this has been asked. So, we will try to find out this situation. So, solution is going to be, students, there are two surfaces. One is this plane surface, fine, another is this curved surface, fine. So, I will apply the formula for two situations. For plane surface, for plane surface 1.5 upon V1 minus 1 upon mr. mr is this distance of object from this lens is equal to 1.5 minus 1 by 1. Fine. So, from here if you solve, you will get V1 is equal to 1.5 mr. No problem, simple formula and simple result. Then for, I think I should use this value, please just V1 is equal to 1.5 mr. Fine. Now use the same space for curved surface. For curved surface, again for this curved surface we are going to use this formula, that is 1 upon infinity. Why infinity? Because image formation will take place, I don't know where, at infinite. Fine. So, 1 upon infinity minus 1.5 upon 1.5 mr plus r within bracket is equal to 1 minus 1.5 upon minus r. Fine. So, let us try to solve it. You will get 1.5 upon 1.5 mr plus r, r are common. So, let us make it like this, 1.5 mr plus r is equal to 0.5 upon r. Ultimately, if you solve this relation, which is not a difficult one, let's give it a try. So, this is 1.5 r is equal to 7.5 mr plus 0.5 r. Fine. Pick this value over here, r are cancelled. So, ultimately you will get m is equal to, from this relation you will get m is equal to 4 by 3. I hope now it is anyway not difficult. So, that is why I mentioned these values. Fine. So, m is equal to 4 by 3 of r. Okay. So, the value of m is 4 by 3. As such, question is not difficult, only one twisting aspect is associated, that this ray is going to be parallel with this axis. So, that is why final image is going to form at infinity. Fine. Now, again this question was not a difficult one, but yes, up to some extent this question may force you to think. Fine. Now, let us move ahead with another set of question. This question is only big in size. As such, question is simple, and the answer of this problem is not as such very difficult. Fine, let us try to read the question first. Diagram is given and this lens is not this much thicker, okay. It is just to show you, that is why specifically we designed the lens in this fashion. Now, two media of refractive index 1.5 with plane parallel boundaries, everything is clear the way we defined the question, are separated by 100 centimeter. Fine. A convex lens of focal length f, value is given, is placed midway. Midway means this straight line if you draw, then this is 50, this is 50. Fine, midway between them, with the principal axis normal to the boundary. Okay. Normal to the boundary means principal axis this perpendicular. A luminous point object O is placed in one medium. Fine. And on the axis of the lens at a distance 125 centimeter. Fine. Find the position of its image formed as a result of refraction through the system. The question is self-explanatory type of question, diagram also given. So, read it the way I read and then try to understand. Fine. What I will do, I will provide you the solution of this particular problem in such a manner so that you can visualize. Because as such no place available over here, so what I will do, I will use this space. Fine. Now, because the question is clear to you, so whatever I am writing, please try to focus on to that. Distance, okay, distance of object as seen by lens. Fine, distance of object as seen by lens is going to be 50 plus 75 upon 1.5 because of the refractive index. So, ultimately how much you will get? You will get it as 100 centimeters, 100 centimeters. Fine. 1.5, so 0, so 15, 5s are 75 and that 0. So, this distance of object as seen by lens is equal to 100 centimeter. Just we calculated. Now, remove out this portion. Then use let us say use this yellow color. Use the formula 1 upon V minus 1 upon U is equal to 1 upon F. Fine. So, 1 upon V minus 1 by minus 1 0 is equal to 1 by 6 0. Fine. So, from here what you will get, 1 by V minus 1 by 100 is equal to 1 by 6 0. Fine. So, from here if you want to calculate the V, it is very simple, 1 upon V is equal to 1 upon 60 plus 1 upon 100. That way you will get V is equal to 150 centimeter. Now, 150, that is this will give you 6000 upon 40. Yes. So, V is equal to 150. So, ultimately it is going to be 150 and minus of this 50. So, that will give you 200 centimeter apparent distance. I think I should use that space of the board. So, apparent, not actual, apparent distance is 200 centimeters. Fine. So, the question was long, but the solution is based upon a simple formula, 1 upon V minus 1 upon U is equal to 1 upon F. So, students, we decided not to create very long videos, fine. Few questions, you can take proper look of these questions, and next time, next video, so again few questions. Point is simple, you should not get bored, you should not feel it as a difficult aspect. So my suggestion is, let me allow to close this discussion for JEE mains exams at this point. Very soon I will be back with a new video. So till then, take care of yourself, keep revising, keep watching these questions and solutions. Have a nice time. Thanks.